Hey guys, today we're going to do section 3 of chapter 11, which is on factoring special cases. So in lesson 11.2, you multiplied polynomials together using FOIL. In this lesson, we present a number of ways to undo this process. That is, we want to rewrite a polynomial as a product of two or more factors, and this process is called factoring. So I believe that we have talked about the X game before, where we are factoring out polynomials, and we did that for quadratics. I'm going to introduce some different cases here that we can use with special factoring formulas, just so that in case you run into them, you know how to factor them. So there are 4 common ways of factoring. You can factor the greatest common monomial factor out, so that's just pulling the biggest factor that everything has in common out, which is where you normally start with. You always start with pulling the largest factor out that you can. Okay? You can use special formulas, which is what we're going to talk about in here. You can use trial and error, which we use the X game in my class, but some people just do a trial and error method. And you can use the factor theorem, which we'll talk about later. In this section, we're going to learn about the first 2. So common monomial factoring. In this method, we're basically taking out the biggest term that everything has in common. So looking at this one here, what's the biggest number that I can take out? Well, I have an x squared in common and I have a 6 in common because 18 is divisible by 6. So I can pull out a 6x squared. And when I do that, I'm left with 1 here and I'm left with 3 here. Okay, now that seems silly because I could have just simplified first, and we'll look at some cases where it'll make a little more sense than that one. Okay, special formulas. There are 3 factoring relationships you should know. So we've got our binomial squares here, and that is when you have either a plus b squared or a minus b squared. Then you'll have something that looks like a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. We also have our difference of squares, so if you have something like a squared minus b squared, we can rewrite that as a plus b times a minus b. So let's go through these different cases here and try to factor them. In this first one here, I've got 9m squared n squared minus 49. So I'm going to start by saying, is there anything that I can pull out? Do these have a common factor? And looking at these, they do not have a common factor because 49, that's just 7 squared, 9, that's 3 squared, okay, and then I have an m squared and an n squared. What I do notice, though, is that this is actually a difference of squares because 9 is squared, m is squared, n is squared, and 49 is a square number also. So I can actually rewrite this as 3mn squared minus 7 squared. So notice that I just wrote the roots of each of those numbers to the second power. And what that tells me is it tells me what my a and b values are going to be for this formula. So now that I can write it as a squared minus b squared, a squared, b squared, I can rewrite that as a plus b times a minus b. So in other words, my a value is 3mn, my b value is 7, and I'm going to write it in that form. So I have 3mn plus 7 times 3mn minus 7. And if you want to check your work, you can always multiply it back out and make sure that you get the same thing. Certainly doesn't hurt to check. Okay, my next one here, I've got 81x to the 5th minus 16x. So the first thing I'm going to do is say, is there anything that I can pull out? And the answer is yes. I know for a fact that I can pull out an x. And I believe I might be able to pull out another number. No, I don't think I can. So I can at least pull out an x, and that leaves me with 81x to the 4th minus 16. Okay, now looking at that, 81x to the 4th and minus 16, do those fall into any of the categories that you see? The answer is yes, it is definitely a difference of squares again. So I know that 81, that's just 9 squared, x to the 4th, that's just x squared squared, and 16 is 4 squared. So I can rewrite this as 9x squared squared minus 4 squared. So this tells me that my a value is 9x squared, my b value is 4, So I can rewrite this as 9x squared minus 4 times 9x squared plus 4. Okay? Now, you might notice that these are both a difference in a sum of squares as well. So we haven't learned how to factor the sum of squares yet, but we do know how to factor the difference of squares, so I'm going to rewrite this one as 3x squared minus 2 squared. Then I'm going to factor it using my difference of squares formula. So this would be the factored form for that equation. Later on we will learn how to factor a difference or a sum of squares. We just haven't learned that yet, so we can't keep going. Alright, this last one here, I've got 4x squared minus 36x plus 81. So looking at that, I know that that's not a difference of squares because I have a middle term there. So that means that it's probably going to be my binomial square. So looking at this one, it looks like it should be this binomial square because I have a subtraction sign here in front of my 36x. So looking at this term, this is supposed to be a squared. I know that that would just be 2x squared. And this term here, 81, that's just 9 squared. So now I just need to check and make sure that my middle term works out. So if my middle term is 2ab, it should be 2 times 2x times 9. So 2 times 2x is 4x, times 9 gives me 36x. That is my middle term. So I know that this is a binomial square. So my a value is 2x, my b value is 9. I can rewrite this as 2x minus 9 squared. Alright, we also have the discriminant theorem for factoring quadratics, and this is on page 688 of your book. Essentially, the discriminant theorem is just talking about that value that would be underneath the radical sign in your quadratic formula. So remember, the quadratic formula is negative b plus or minus radical b squared minus 4ac over 2a. So we're looking at the b squared minus 4ac part. Since that's normally under a radical sign, I know that if this number here is positive, you should get 2 real solutions. If this number here is 0, you should get 1 solution because it'll just end up being negative b over 2a. And if this number here is negative, then you're going to get 2 complex solutions, meaning that you won't have any real solutions for your quadratic because you'll have a negative underneath your radical sign. So you'll have to start using I, which we will get back to in this chapter. And that is everything for section 3.